All right. So, tell me a little bit about this particular design, the bike.
Yeah, well,
What's your secret sauce?
secret sauce.
Yeah.
Well, the designs
First
are
of all,
all
let's see. Your what's the team?
the Cal Poly.
Cal Poly. Okay.
Yeah, I'm the advisor from Hydroforce, mentor. So this particular bike, I guess, these guys know it more than I do, but they did put a lot of work into designing a ground-up frame for it.
Right.
It's dedicated.
Oh, so this is not a prefab frame. This was.
They built this from scratch.
What was the reason for that? So why?
Just to integrate the mountings and for the pump and motor and the accumulator mount more efficiently, and get a geometry that was kind of more appropriate for something with this much potential for power and speed. And the other nice thing is the pump is actually on a planetary drive. So in both the pump and motor are these very small displacement, high efficiency piston pump and motor. So there's a lot of efficiency in the drive components.
What do you think that will get you in the judging, and in terms of where do you anticipate this design will make you strongest? Which categories?
I think from what I see, probably more the efficiency part of the competition.
Energy efficiency?
Yeah. I think it's a fairly light bike compared to the rest of the. And part of that is because they designed a dedicated frame, use lightweight components. I don't know if you noticed, but the pump and motor they're very, very small. They're also aluminum bodied, so they're lighter than some of the other solutions.
Yeah, one of the other teams, that was a lesson learned for them. They made too big of a hydraulic reservoir.
Yeah.
It was like I'm dangerous with the designation, but so it sounds like smaller is better.
Yeah, it's kind of in hydraulics, you lose a lot. The losses due to velocity through the plumbing is it's a square? Anyway, it's substantial. So if you can trade pressure for flow and get the same horsepower, you're more efficient because you have less losses. Because you're using higher pressure to achieve your horsepower, but the flow rate through all your passages is lower, so you gain efficiency that way. And you tend to end up with smaller components that are lighter and easier to package, and especially something like this.
Tell me about the members of your team. Are they all mechanical engineers?
Yeah.
Or?
Well, mechanical and mechatronic engineers.
Okay. So this is their first exposure to hydraulics for a lot of them, or?
No, they've been on other projects, and
have they?
I think a couple of them were on the Formula SAE competition for a few years before this. So they've been through. Had other exposure.
Does that give them a leg up, do you think, in this competition, that they've had previous exposure?
I guess so. This is my first year, so they're sharp guys. So I don't know whether that would have slowed them down not to have that or not. I don't know.
What have you taken away from this?
That's. I think it's just an excellent format to promote hydraulics in general in a world where hydraulics is not sexy, and a lot of the smart minds are going into more high-tech fields. It's good to promote it and have the ability to bring in new talent and keep the industry going, because I'm seeing the demographics from what I see is just generally getting older and older, and industry, and then, we got to shift that. And I think this goes a long way to do that.
Well, there are certainly more females, it seems, in this
and
competition.
right. As well.
Let's see. Let me make sure it's Mark Declar,
Yeah.
and you're with Hydroforce.
Yeah.
Thank you very much, Mark.
Thank
I
you.
appreciate it.